Welcome back to another episode of my science series. Today we are going to be talking about mixtures and solutions. In our previous lesson, we talked about matter and the particles of matter. We knew that we had 3 states of matter: solid, liquid, gas, and we also learned about our different physical properties. So anything that has to do with magnetism, solubility, mass, density. Anyways, we have to now talk about mixtures and solutions. So, what is a mixture and solution? A mixture is a combination of 2 or more different things mixed together. However, there's a lot to do with the actual physical properties of a mixture. For example, let's take gravel and water and put it together. So, here I have my gravel. I'm going to go ahead and pour some water in here.
Oh my God!
One physical property I can already observe is relative density. I know that the gravel has more density than the water, so that's why it's sinking to the bottom. So a mixture is something that can be easily separated. I don't have to do any other physical changes to my ingredients in order to change them. I have, number 1, a pipette. If I wanted to go ahead and squeeze out the water with the pipette, this is a tool that can help me separate my mixture. However, it's not exactly the best way to do it, because if I had 30 pipettes, I would be able to do it quickly. But for right now, I only have 1, and it's kind of taking a little bit. Let's pour the water back in this cup. Now, the next tool I have is a magnet. If I have my magnet, I need to figure out how I can use this to separate it. Now, in general, we already know that not all metals, but some are attracted to a magnet. My gravel, my rocks, they're made out of materials that aren't even magnetic. So if I put it into my beaker, it's not going to pick up any of the materials. Another tool that I could use are pinchers or tweezers. Now, these little guys help out a lot getting small materials from mixtures. But if I actually try to go ahead and grab a rock, it's going to take me a really long time. Okay, so far I have 15 rocks and it took me about a minute or so. But yeah, not really effective. One way that I can easily separate my mixture is literally just pouring it out. My rocks are so dense that it just floats on top, so I can just separate my water without having to do any other extra tools. There you go. So the next part of our unit is understanding what a solution is. So, a solution is also a combination of 2 or more different things that mix together. However, the particles go ahead and spread apart, making it difficult to separate. Now, here I have another beaker of water. In my beaker of water, I'm going to have 2 more ingredients. I have sugar cubes, and then I have some powdered Kool-Aid. Now, with my sugar cubes, I'm going to go ahead and plop them in. There they go. I'm going to make sure I stir my water, and my sugar particles are going to go ahead and dissolve. Now, when it comes to solutions, solubility is a huge component of our solutions. Why? Because like I just said, the particles break apart, and I can't grab the sugar, I can't individually take out the sugar particles. I can't grab tweezers, I can't use a strainer. They're way too small for me to separate. Okay. Now, I noticed that my water is basically almost clear. There's a couple little sugar cubes or sugar little particles moving around. Now, you notice how the water is still clear? This is what we call the conservation of matter. I know that I have water and sugar mixed together. It looks like the sugar disappeared, but it's still inside. I still have all the sugar particles in here. They just decided to get smaller and smaller and smaller, so I can't see them. It's not that they disappeared. They just broke down to where I can't see them at all anymore. Now we're gonna go ahead and mix in our Kool-Aid powder. I immediately start to notice that the particles are breaking apart and it's changing the color of the water. My particles are getting smaller once again. I now have a completely new substance.
Slay!
My water isn't clear anymore. I don't even have water. Now I just have Kool-Aid. I have water, sugar, and powder to mix together. This is completely different from what I had before. Even though it's still made up of the same materials, it's technically a new substance. And that's what we mean when we say conservation of matter. The ingredients are still there. They didn't disappear. It's just now together and forming something else new. We are back at the vision board. So let's go ahead and talk more about our specific vocab words that we're focusing on. First, we have a mixture. What is a mixture? A mixture is basically a combination of two or more different substances. Now, here's the key thing we need to understand when it comes to mixtures. The ingredients in a mixture don't change any other physical properties. That's why we call it a mixture. Now, here we have an example of salad. In my salad, I know that I have lettuce. I have spinach, red onion, cheese, croutons, and ranch. Now, I can get a specific tool, like tongs. Tongs are great for being able to separate the different parts of a salad. This is how I know a salad is a mixture, because there's no new changes. No matter how many ingredients you put, if you add cherry tomatoes, if you add almonds, strawberries, every single part is going to be able to be easily separated. And that's the biggest thing about a mixture. A mixture can be easily separated using tools like magnets. If I wanted to mix salt and sugar, I can easily separate it. However, the particles are pretty small. If I have sand and water, the sand is going to sink to the bottom. If I have iron filings and sand, I can get a magnet to separate all the iron particles. Anything that can be easily separated, especially with tools, is going to be a mixture. And here's another important thing to know. Because of that, the particles of a mixture don't break down. They don't change, they don't do anything. The particles are still remaining the same. So whenever you think of a mixture and you're observing a mixture, you know it's going to be like that because none of the particles are changing. Let's go ahead and look at solutions. So, our solutions. A solution is a combination of two or more things that are creating something new. Now, when I mean new, I'm just really talking about that the ingredients in a solution are changing their characteristics. You're still going to have the same ingredients. They're just changing a little bit and their particles are breaking apart. Now, when I say a new substance is made, it's changing either the state of matter, the color, some of the other properties, such as its thermal conductivity, its mass. Here's an example. I have my Kool-Aid, my delicious grape Kool-Aid. Here I have powder mix, I have sugar, and I also, of course, need to have water. Now, solubility has a lot to do with a solution because it has to break down and spread its particles apart in that liquid. So here, the particles are breaking apart. My purple Kool-Aid powder is dissolving in the water, and that's what helps me have my delicious, refreshing drink. So, the particles are so spread out that we can't take them apart. It's going to be really difficult in order to get those Kool-Aid and the sugar particles back because they've already spread apart so much. Here's another thing. If I had a physical change to a solution, so I mix everything together. My sugar and powder, they weren't a liquid before, they were solids, but now they spread out and they're part of a liquid. If I have to have a physical change to create that solution, I have a physical change in order to get back and separate the different parts of the solution. That's how I know I can get their own properties. Here, I have a change in temperature causes particles to expand and heat. Also, a change in temperature can also cause the items to contract and the particles get closer. So remember, solutions are objects that can't be easily separated. On the other hand, mixtures can be easily separated, whether you can use your hand, your tool, or another type of physical property. Bye!
Let's now go ahead and investigate the different ways we can get mixtures and solutions. Now, remember, any experiment that you can do at home doesn't always have to be very messy or very difficult. You can always find simple things around the house that you can have fun with. Example, I'm using tea. I have my 4 main ingredients, my tea leaves, my water, my sugar, and my milk. I put all of these together and I see that my tea leaves are dissolving. I also know that my milk is dissolving and my sugar is breaking down. Now I have my yummy drink. The next thing that I'm going to look at are beads. So, I still like to make friendship bracelets and cute little trinkets and whatnot. So I have different size beads. I notice that it's a mixture, a combination of different colors, different sizes. I want to go ahead and separate a couple of them, show them off. Remember, you don't have to do anything crazy. All the science is around you.